Hi, hello. This video is on lines and angles. So the first type of line that we're going to look at is a parallel line. And parallel lines are lines that do not intersect, or coplanar lines that do not intersect. And we use a little symbol for this, and it kind of looks like two little mini parallel lines or two diagonal lines. We use that to say that two things are parallel. Now, another type of line that we're going to look at is a skew line. And skew lines are lines that are not coplanar, so they're not in the same plane. And they do not intersect. And they're not parallel. And we'll kind of look at a couple of examples down in here in this image of what skew lines look like. Parallel planes are planes that do not intersect. So now what we're going to do is we're going to look at this image right here, this rectangular prism, and we're going to identify lines that are parallel, skew, and parallel planes. So remember, parallel means that things do not intersect. They look kind of like these two little lines right here. There's a lot of sets of parallel lines in here. We'll just identify a few. Let's start right here at AB. AB. So I'm looking for things that do not intersect AB. They do not intersect AB. So we could have AB is parallel to DC, because these two lines go on and on forever and ever, and they're never going to intersect. So the way that we would write this is we would say the line segment AB is parallel, we use that little symbol, to DC. There's other ones that we could say that are parallel to it as well. FE or HG are parallel as well. Let's look up another set of parallel lines though, and we'll do EH. We could do EH. Remember, we use our correct notation. EH is parallel to, well, it's any of the ones that it's not going to intersect with. So we have AD, we have FG, even BC could be parallel. So we would use our little parallel symbol, and we could say any of these. Maybe we'll say FG. Skew lines are lines that are, remember, not coplanar. They do not intersect, and they're not parallel. So let's start with CD. Is it what we want to find something that's parallel or perpendicular? I'm sorry, skew to CD. So it can't be parallel. So it can't be AB. It can't be EF. It can't be GH. It's not going to be AD or BC because those intersect with CD. So we're looking for something that does not. So we can say CD is skew to, and we have two lines that we can be. It could be EH, because EH does not intersect, nor is it parallel. The other one like that is FG. Parallel planes, remember, these are planes that do not intersect. So think of a plane as kind of like, if this is a box, the top, the bottom, and the sides. So if I was looking at the plane, let's look at the top and the bottom. Those are parallel. Um, they're never going to intersect. You could think of like a room. The floor and the ceiling never intersect. Remember, to name a plane, we use the 3 letters. So we could say A, B, C is parallel to, and then we're going to do this bottom part. So E, F, G. It says 2 pairs, so we could do the top and the bottom. We can also do kind of the sides as well. So we could do A, E, H is parallel to, so that's the front side. So then we would have to do the back side of B, F, G. All right, another type of line that we're going to look at is called a transversal. And a transversal is a line that intersects 2 or more coplanar lines at distinct points. So if I look at this image right here, our transversal is this right here. We'll draw an arrow to that. That's the transversal. This line T. So we have 2 lines and a transversal. Now we're going to look at some special lines where we have 2 parallel lines and we say it's cut by a transversal. So a transversal goes through both of those. And we're going to look at some angle relationships with those. The first thing that I want to identify is what we call an interior angle. Interior meaning inside. So we're looking at the inside angles. So I'm looking in between my 2 parallel lines. So we have angles 3, angles 4, angle 5, and angle 6 are what we would call an interior angle. They're on the inside. Exterior meaning outside. So they're outside of the 2 parallel lines. We would have angles 1, angle 2, angle 7, angle 8 are our exterior angles. Interior inside, exterior outside. So we're going to use those as we kind of identify some unique relationships with our 2 parallel lines cut by a transversal. So if you'll flip to the back page, we're going to look at some of those relationships. The first one that we're going to look at is what we call alternate interior angles. So that means we're looking at the inside, and alternate meaning kind of like opposite. So they're non-adjacent interior angles. So that means they're not right next to each other. That lie on the opposite side of the transversal. So we can look at down here. So we have to be inside and they're non-adjacent. So they're on opposite sides of the transversal. So alternate interior would be a 2 and an 8. They're inside and they're on opposite sides of the transversal. So 2 and 8 are angle 2 and angle 8 are alternate interior angles. We also have another set of alternate interior angles, and that is 3 and 5. Angle 3 and 5. Alternate interior angles are always what we call congruent, meaning that they have the same angle measure. These are always congruent. Same side interior angles, they're on the same side, and they're inside angles or interior angles. So they're interior angles that lay on the same side of the transversal. They're on the same side of the transversal. So looking at that, inside angles, so we're just looking at these, and they're on the same side of the transversal. So we'd have 2 and 5 and 3 and 8. So angle 2 and 5 and angle 3 and angle 8. These types of angles are always supplementary, or they're going to add up to 180. They're going to add up to 180 degrees. Corresponding angles are angles that are on the same side of the transversal in corresponding locations. I want you to look at this image right here and notice angle 1, 2, 3, and 4 look a lot like angles 5, 6, 7, and 8. Notice they're almost like if I took this and put it over top of it, they'd match up. And that's what we're looking with at corresponding angles. Angles that kind of match up, that they're in the same location. So like angle 1 is in the same location as angle 5. So they are corresponding. Angle 2 is in the same location as angle 6 in this intersection. They're in the same location. So those are corresponding, angle 2 and angle 6. Angle 4 and 8 are in the same location. And then 3 and 7. So angle 4 and angle 8. And then we have angle 3 and angle 7. They're in corresponding locations. Because they're in the same location of these, they are always going to be congruent. All right, lastly, we have alternate exterior angles. So they're non-adjacent exterior. Now we're looking at the outside. So 1, 4, 6, and 7. They're non-adjacent exterior angles that lie on opposite sides of the transversal. So like how we had opposite or alternate interior angles, now we can have alternate exterior angles. So that would be something like angle 1 and 7. Or we could have angles 4 and 6. All right. And so that's the first thing that we're going to do is you're going to be identifying kind of these relationships in images like this. So I might say, what's an alternate exterior angle? And you would say, in this case, 4 and 6. Or I might say, what relationship does angle 2 and 8 have? And you would say alternate interior angles. So we would go through these. And then as we kind of started talking a little bit about those relationships, we're going to end up solving problems with those.